Hello all, welcome back to 271 Math. First, I'd like to apologize for my long absence. I had AP and final examinations, but now that I'm done, I'll be able to make content all summer long. I think a really great way to ease back into lessons is teaching conversions for decimal, binary, and hexadecimal. But first, what are they? Decimals are a classic base 10 system, binary is base 2, and hexadecimal is base 16. Decimal uses numbers 0 through 9, binary uses 0 and 1, and hexadecimal uses 0 through F. I think it'll be made obvious how to convert once I show some practice problems. So our first example is asking us how to convert 43, which is decimal, into binary. So first, we need to remind ourselves of the powers of 2 starting at 0. We need to go until our result is the largest base 2 value that doesn't exceed our decimal. This number is 32, so that would be 2 to the 5th. 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, and 2 to the 5th. So 2 to the 0 is 1, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16, and 2 to the 5th is 32. This ensures that we have enough binary digits, also known as bits, to represent our integer. For each possible digit, I'm going to use an underline as a placeholder to represent each of the base 2 values. Each bit needs to be represented whether it's in our answer or not. So let's do that real quick. So we have 6, 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, and 2 to the 5th. As a reminder, with binary, zeros represent off while ones represent on. Now, our first step is to find base 2 values that add up to 43. We always want to find the largest value that could go into our decimal and then subtract that from our integer. So right now, the possible greatest value is 32. So I'm going to box that, mark it as on over here, and then add it over here. 43 minus 32 is equals to 11. Let's see if 16 can go into that. It cannot. 16 is greater than 11, so we cross that out and say that this is off. Now we have 2 to the 3rd, which is 8, which is lower than 11. So we mark that as on, box it, and subtract it from our integer. So we have 8 plus 3. The reason I am boxing it is to easily show that these are used in calculating for the binary equivalent. So far we have 1, 0, 1. So now we have 3. 4 is greater than 3, so we cross that out. We do not use that. However, 2 and 1 are used to add up to 3, so we box both of those and represent that over here. So we have 2 plus 1. Because we crossed out 2 to the 2nd, we mark that as a 0, meaning that it's off. It is not used. 2 plus 1, they are used, so they're represented with 1s. And this is our final answer. 1, 0, 1, 0, 1, 1. Let's verify our answer to see if this is true. Binary is calculated right to left, so we gotta start from 2 to 0. We have 1 plus 2 plus, we skip the 2 to the 2nd because it's off, but we have 2 to the 3rd, which is 8. We skip 2 to the 4th because it's off, but we have 2 to the 5th, which equals to 32. 1 plus 2 is 3. 8 plus 32, that's 40. 3 plus 40 is 43, which is the same answer we got here. So that is our answer for example problem number 1. Now, this example is asking us to convert 9F, which is hexadecimal, into binary and then decimal. We need to represent each hexadecimal digit with 4 binary digits. I'll be referring to each 4 digits as a group. So let me write down each group. So that's 1 digit. This is going to be equals to 9. And then this one's going to be equals to F. So with hexadecimal, I wrote down its decimal equivalent. So 0 is equal to 0, 1 is equal to 1, so on, and then A is equal to 10, B is equal to 11, and so on from there. I figured this would make the conversion into binary much more easier. So for 9, we need to find the equivalent in binary. So we need to convert 9 into binary. So 9 is just equal to 9 in decimal. So that'd be 1, 0, 0, 1. Because 2 to the 0, that's 1. 2 to the second, we don't add that up. 2 to the third, we don't add that up. But 2 to the third, we do add that up. So it's 0 plus 1, that's done. That's 9. And with F, we gotta find the sequence of bits that add up to 15. So that's just going to be 1, 1, 1, 1. And that's our answer. We have 1, 0, 0, 1, 1, 1, 1, 1. That's our answer for hexadecimal. Now we could convert this whole sequence of bits into an actual decimal number, because binaries read from right to left. We have to do it that way. So we have 2 to the 0, which is 1, and 2 plus 4 plus 8 plus 2 plus 4 plus 8 plus 16. We skip 32 and 64, and we go right to 128 plus 128. So we have 3 plus 12 plus 144. So I have 15 plus 144, which equals to 159, which is our answer. And that's how easy it is to convert binary to decimal and hexadecimal to binary. And that's it for this video. Thank you for watching. Hopefully I made this explanation easy enough. If not, please let me know in the comments and I'll make an extra part to this. Thank you for watching, and I'll see you guys next time.